So, hello everyone. Today is the bonus lesson, and today we'll be covering paper one of the IGCSE Math syllabus based on the 2025 to 2027 syllabus. So, first, before we move on to the paper itself, some general information is given here. So, as you know, there's a very big change that has been uh, published by the Cambridge Board from 2024 to 2025. So previously in 2023 and 2024, both the papers includes calculators. So the scientific calculators allowed for both the papers. So as you can see, the scientific calculators are required for both the papers. The big change over here is that the 2025 syllabus, there is a non-calculator paper. So this non-calculator paper is for paper one, which means that you should be able to solve questions without using a calculator. Generally, these questions would be easy and straightforward, but sometimes it can be tricky, and you need to spend more time in any of the questions. So, if you just know that, I think we can just move on to the uh, paper itself. So, the other stuff like the syllabus and all, more or less, it's the same. So, let's just move on. This is my first time doing this, so let me just gives a thumbs up if you're able to hear me well and see the screen. I'll just check it once more. Okay, the microphone is on. Okay, I hope you can hear me. And now let's just move on to the paper. So today we'll be doing the Feb March 2025 0606 paper 1 variant 2. And the total duration remains the same from before. It's going to be 2 hours. And just heads, it's a non-calculator paper. So I will not be using calculator for this too, just to help you how to answer each question without a calculator. So let's start. So since it was a non-calculator paper, they gave you a list of formulas. Just if you want to refer to it when if you do not remember any of those general formulas, they are given here. So let's just get started. So the first question. On the axis, sketch the graphs of y4 to the magnitude of x minus 1. So this is basically the absolute value of x minus 1. And y is equal to absolute value of 3x plus 2. Stating the intercepts with the axis. So intercept as in you need to state the x as well as the y intercept. So x and y intercept. So let's just go and sketch this graph. So basically, a general absolute value graph should look like a V. So the shape should be V. So we need to just know where the intercepts meet, and then you just draw the gradient or the V based on it. So here it is 4 times the absolute value of x minus 1. So that brings you to this. So x minus 1, when you have, let's just find the x and y intercepts. And how do we find it? Let's find the y intercept for the first equation. Y intercept. So what you do, you just let x to be 0 and then you do the rest. So y is equal to 4, 0 minus 1 absolute value. So that becomes 4, negative 1 of the absolute value, which brings you to 4. So you can just sketch that 4 over here. So this is 4. And the y-intercept of this graph. Or let's just deal with one graph first. So let's deal with the first graph first, then we can move on to the second. So the x-intercept of the first graph. So the x-intercept. You know that there will be so the x-intercept here will make you need to set y as 0 and then you just do the normal x minus 1 So it should be absolute value of x minus 1 and equals to 0. So now x minus 1 gives you 0. So either x minus 1 is equal to 0 or 1 minus x equals to 0. So either way, since it is a 0, uh, x should be equal to 1. So because in both the cases you will get x is equal to 1, so you can just have one of the, so the x-intercept will be 1. Sometimes this might change if there is a positive value that is greater than 0, integer greater than 0, you need to square both sides or use the formula to find it. So since it is 0, we do not care about the both the cases here because both the cases will give you the same answer. So now we will move on to the second graph. So as I told you, the first graph should look like a V touching this point and moving towards the upper side, up something like this. So this will be your answer. For this is only for linear equations containing the absolute value because any linear straight graph will be a straight line, and since it is the absolute value, it should not go below the x-axis. So that's why we move the we reflect the points from the below the x-axis to the above the x-axis. So that's why you get this V. So now let me just get a clear slate for the second graph. So the second graph, we have the y-intercept to be, so y-intercept you let x is equal to 0, y is absolute value of 3 times 0 is 0, 2. So that gives you 2. So the y will be 2 over here. So let me use a different color to just differentiate both the graphs. So it is 2. And then the x-intercept, the intercept would be, so you make the x is y is equal to 0, so that gives you 3x plus 2 equals to 0. Sorry, so since it is 0, we do not care, both the situations is more the same. So 3x plus 2 equals to 0, x equals to negative 2 over 3. So we can just put that over here, so it should be somewhere here, negative 2 over 3. So that's your x-intercept. And when you're drawing the curve, the graph, sorry, it should look the same shape, but it should touch these two intercepts. So let me just make that clear. Okay, that should do. When drawing this, make sure you use the scale, so it's a straight line and not freehand. So just keep that in mind. So that's part A. Part B. Now they're asking you to solve this inequality. So basically 4x minus 1 is less than or equal to 3x, absolute value of 3x plus 2. So at this moment, you should just think of, first, there are two ways to do this as we did it in the sessions previously. So one is squaring and the other is taking all the cases. Take all cases. But since here there are two absolute values involved, I would recommend not to go with this because sometimes you might miss some of the cases. If you're losing any of the cases, you might get the answer wrong. So best way is to go for squaring. So let's do the squaring method. So the squaring method, you usually square the whole thing. So basically 4 times x minus 1 the whole square, and then this should be 3x plus 2 whole square. So now this 4 squared will be 16, x minus 1 squared less than or equal to 3x plus 2 squared. Now when you expand it using the formula ax plus b squared, so this is the formula over here, ax squared plus 2ab plus b squared. So this is your formula, and when you apply this formula here, you get x squared minus 2x plus 1. So let me just give it another color, so it's, if you can remember, this is the formula. So now this should be 9x squared plus 6. So 3 times 2, which is 4, times 3, which is 12x plus 4. So now this becomes 16x squared minus 32x plus 16, and then 9x squared plus 12x plus 4. Now what you do, you transpose one of the sides to the same side, so you get 16 minus 9, which is going to be 7. So 7x squared minus 32 minus 12 will be minus 44, and then plus 16 minus 4 would be 12. So that's going to be this. So now you need to apply the solution method. How do you are going to find this inequality for the ranges of x? So basically what you do, you can either do this by the factorizing method, squaring the formula, and or use the formula method. So here let me just go with the factorizing method to show you how it is done, and because since it is non-calculator, most of these answers will be a whole number, so it's better to go with factorizing method. So when you use the factorizing method, you get the values to be x minus 6 and 2x, so yeah, x minus 6, 2x minus 7, or no, sorry, 7x minus 2, sorry, 7x minus 2, because 7x times x is 7x squared. So after you get these two values, you just plot it. You just draw a rough sketch of the inequality and find the shaded region. So this is basically the easiest way to tackle inequalities involving quadratics. So since this is a positive 7x, the x squared has a positive coefficient. The graph should look somewhat like this, and the 2 points would be 2 by 7 and then a 6. So since it is less than 0, so that means it should be below the x-axis. So since above the x-axis will be positive y values and below the x-axis will be the negative y values. So since the y value should be less than or equal to 0, we will just shade this part. So this is your region. And where does this lie? Between the 2 by 7 and the 6. So the critical values of 2 by 7 and the 6. So it lies between. So therefore, the answer here should be 2 by 7 less than or equal to x is less than or equal to 6. So hope you got it how to solve. So this question is for 4 marks. So they are asking you to use a lot of knowledge from your whatever you studied, and you need to apply various different knowledges at each step. So here first we did the squaring, then we used this formula to expand, and then use the inequality form to solve it. So there are 3 steps you need to cover when you're solving this type of question. So hope you got the first question. We are done with the first. So now let's move on to the second question. So basically, the second question here is a trigonometric graph. So they have given you what trigonometric graph it is. It's a cos graph, and you need to find the values of A, B, and C. So this is straightforward. Just you need to know where is the mean position of this graph. So the mean position will be somewhere here. No. Okay. So you just find the mean position. The mean position is basically the number of the altitude ups towards the up and the down should be equal. So that's your mean position. So if So here it is. So this is your mean position. So you can see that the number of units up is 1, 2, 3, 4, 5, and the number of units down is also 5. So when the number of units up and down is 5, that's your mean position. Usually for a basic y is equal to cos x graph, the mean position would be the x-axis starting from 1 to -1. Here there is a transpose, or there is a stretch in the up and down. So that's why we see a altitude of 5. So, so now what does this A consider? So A, for this A, this is the altitude. You just need to know which is the altitude, which is the period, and which is the transition of the graph. So B is the period as in the number of cycles in 360 degrees for cos graph, and this is the transition. So now A is the altitude. The altitude is of course 5. So you can just write altitude to A is to be 5, and B is the period. So you can see here the period directly. So basically this graph, this is one cycle, and then another half cycle. So this is basically half cycle. So 1.5 cycle is covered in 180 degrees to 360 degrees. So let me just write it here clearly. So 1.5 cycle is covered in 180 degrees, which means from a general point of view, from y is equal to cos x, that's your general graph you need to compare with. So one cycle goes for this is 360 degrees. For 180, if it is 1.5, for 360 you just double the number of cycles. So therefore for 360 degrees the number of cycles would be 1.5 times 2, which is going to be 3. So that's your B. So that's your period. So B is equal to 3. So hope you understood how the period is calculated. You need to just compare your value, whatever you get from the graph, with 360 degrees to get the period. Because as you know that a cos x graph will be, cos x general graph will be for one cycle, it will be 360 degrees. And C, the value of C is the transition. So again, you need to compare it with this cos x graph. So basically in a cos x graph, it will be from 1 to -1. And since here it's already 5, so it should start from 5 to -5. So the altitude is changing, so you start from 5 to -5. But here it starts at 3. So what has happened from 5, you have moved the graph 2 steps down. So you have moved the graph 2 steps down. So that's why your C should be -2. Because when you move 5 minus 2 is equal to the 3 you got here. And -5 minus -2 will be -7. Sorry, -5 plus -2 will be -7. So I have moved the graph 2 steps down from the altitude. So that's how you calculate the C. So hope you understood. This is a pretty straightforward question. So you will get 1 mark for each of this answer. So 1 mark for each value you find. So that's why it's for 3 marks. So now let's move on to the third question. So the third question is asking the point A has coordinates -3, 6. The point B has coordinates 7, -8. Given that the line AB is the diameter of the circle, find the equation of the circle. So you have 2 points, and you have said that when you join those 2 points, that's your diameter of the circle. So from this you can easily find the radius. So the step 1, let's just do the step 1 first. Let's find the radius, because for the equation of the circle, as you know, the general form is x minus a squared plus y minus b squared equals to r squared, where r is your radius, A and B are the coordinates for your center of the point. So you need to find the radius and the center of the point here. So radius, you find it using the length formula for the from the coordinate geometry of circles. So the length formula. Okay, so first let's find the diameter. So the diameter, as they told, is AB, which is going to be equal to, so the diameter AB is going to be equal to the square root of uh, -8 minus 6. So -8 minus 6. So that's how you do that. And then you minus from 7 to -3. So that plus 7 minus of -3. And then you square that both the values. So now you get 14 squared plus 10 squared. So how we got the 10? 7 minus of -3 will be plus 3. So 7 plus 3 is 10. So from that you can just go do it. 196 plus 100 is equal to 296. So since square root of 296 is not an exact value, you can find the radius directly from it. So the radius, you can just leave it as it is, and then you can just find the radius. So the radius would be square root of 296 divided by 2. So what you can do is you can just make it to this square root inside, 296 over 4, because you know 2 squared is equal to 4, and when you square root 4 you will get 2, and then 296 divided by 4 you get square root of 74. So now you have got square root of 74 as your radius. So then you have already found r squared. R squared will be, so r squared would be 74. So the part 2 which you need to solve, so I'll just shrink this to get more space. So the part 2 or the step 2 you need to solve is for the center of the circle. So how do you find that? You know that this is the diameter, and a diameter always passes through the center, dividing into two equal radii, or you can say like that. So then the midpoint of these 2 points should be the center, right? So what's our idea over here? Since AB is diameter, and a property of a diameter, you know that it is, and that it can be divided into two equal radii. The midpoint of the line, the midpoint of AB is the center of the circle. So that's your idea here. So how do you find this midpoint? So it's pretty easy. So let me get some more space. So it's basically you use the midpoint formula. M is equal to, you add the x coordinates, -3 plus 2, 7 divided by 2, and you add the y coordinates and divide that by 2 as well. So -6 minus 8 divided by 2. So you get the x coordinate and y coordinate of the center to be 2, -1. So that's your midpoint. So now you can just or club your information together into the equation of the circle. As they told you to find the equation of the circle, you can just find it by substituting the values to this part. So that would be x minus a is your x coordinate. So x coordinate of the center, 2 squared plus y minus -1. So minus of -1 would be +1. So that's squared. And then your r squared is, as we found, it's 74. So that's your equation. So hope you got this question. So one of the new topics in the 2025 to 2027 syllabus is the coordinate geometry of circle. If you are not confident with this topic, you can revisit our video, which is linked above here somewhere. I'll put it in the description box also. So now the let's go to the fourth question. So the fourth question is from the polynomials, factors of polynomials chapter. So now it's given, the polynomial is given by px ax squared x cubed plus 2ax squared plus 2ax plus 2. It is given that 2x plus 1 is a factor of px and a is a positive integer. Find the value of a. So from this you need to just, they have told you that 2x plus 1 is a factor of px. So then you need to go to the concept of factor theorem. So by factor theorem, this is how you write when you're solving, you're telling the steps. So by factor theorem, you can set the 2x plus 1 to 0, and the x value you will get is negative half. So now you need to just substitute this negative half into px, and the resulting answer should be 0 because it's a factor. So that means the remainder should be 0. So now when you do p is negative half is equal to 0, when you equate this, you get a squared negative half cubed plus 2a negative half squared plus a negative half plus 2 equals to 0. Now when you do the expanding, so negative 1 over 8 a squared plus, this should be 1 over 4. So then 1 over 4 times 2 would be half a plus minus, so since it's a negative here, negative half a. So let me just get that correct. Yeah. And plus 2 is equal to 0. Now you can group the terms, the like terms. So half a minus half a will get cancelled. So you can just cancel these two. And then you get plus 2 equals to 0. So now you can understand that from this you can get 1 over 8 a squared equals to 2. You bring the negative 1 over 8 a squared to the other side, you will get 0 plus 1 over 8 a squared. So that's why you get 1 over 8 a squared equals to 2. And then let me just write it here. So a squared, then it will be 2 divided by 1 over 8, which is 2 times of 8 a square, which is going to be 16. So then a is equal to plus or minus 4. Since they told a is a positive integer, you need to reject the minus 4. So the minus is rejected because a is greater than 0. So therefore a should be equal to 4. So it's important to write this rejection. So this at least, like, it might carry 1 mark if, but here since it is just for 3 marks, I think the steps are okay for getting those 3 marks. But if it's more, you need to just write this rejection, why it is rejected, the reason in brackets. So the examiner can understand that you have understood the concept well and you have read the question properly. So then let's go to the part B. So hence factorize px. So you know already one of the factors of px is 2x plus 1. You can just substitute this to find the px first. So the px should be 4 squared x cubed plus 2 times 4 x squared plus 4x plus 2. So that should be 16x cubed plus 8x squared plus 4x plus 2. So now you know that One of the factors, you just apply long division. So I feel it's easy to apply the long division method when solving for the quadratic function. So long division, let me just show you how to use it if you're new to that concept. So this divided by 2x plus 1, 2x plus 1. So now what you do is you just find the what you need to multiply with to get 16x cubed. You need to multiply this 2x times 8x squared to get 16x cubed. You saw how I got 8x squared because you're multiplying the first term, which is 2x, with some term which gives you 16x cubed. So that is 8x squared. And then this 8x squared, you can just write it. You multiply it with 1, you get 8x squared. You get a 0 for this. So then you can write 4x plus 2 down. If there is a remainder, you just bring it one by one. Since there's no remainder, I have brought both the terms down. And then this should be plus 2, which gives you 4x plus 2, which is going to be 0. So your quadratic equation, the other factor, quadratic factor, will be 8x plus 2. 8x squared plus 2. So px can be factorized as 2x plus 1, 8x squared plus 2. I think you can just leave it at that because it's only for 2 marks and you cannot further factorize this. Further factorize the 8x squared plus 2. At least you can just bring the 2 outside and write 2x plus 1 and this should be 4x squared plus 1. So that's all you can do with that. So that's your answer. And let's move on to the part C. So hence show that the equation px equals to 0 has only one root. Px equals to 0 has only one root. So when you're solving px equals to 0, you can just write as it is. You will be solving for 2x plus 1, 4x squared plus 1 equals to 0. So now you can just separate each term. You just divide 0 divided by 2. You can take off this 2. This 2 doesn't matter because when you divide the other side, it will be 0 itself. So now you can separate these two terms, writing 2x plus 1 equals to 0 and 4x squared plus 1 equals to 0. For this, the x should be negative half. And for this, what happens here is the x squared would be, so what we do is you bring the plus 1 to the other side, you get negative 1. And when you do the x squared, it will be negative 1 over 4. Now the problem arises here. So since x squared is less than 0, x has no real solutions. No real solutions. So you cannot square root a negative value as it is unless you can use it to find the complex number. But since they are asking only for the real root, the real solution, you just write x has no real root because x squared is less than 0. So that's your reasoning. So this is basically your reason, and you can just write shown. We have showed that since x squared is less than 0, the x has no real solution for this, and only one solution is a negative half. So hope you understood how we did that, and let's move on to for the fifth question. So the fifth question here, we have to write this quadratic function in the form of completing the square. So when you see this kind of a times x plus b squared plus c, you immediately realize this is your completing the square form. Completing the square form. So now when you do the completing the square, you just do it as you have been taught. So I'll be doing it this way. So I'll just first write this 2x squared minus 2x plus 3, right? So what I will do it, I will factorize it by 2 because I need to take this 2 out so it can have only x squared when you do the the completing the square. So when I take 2 outside, you get x square minus x plus 3 by 2. So how are you saw how I got that 3 by 2? And now what we do is we do the completing the square as it is. So what we here it will be x plus, so let me give a square brackets to make it clearer. X my plus, so wait, yeah, so it should be x minus half squared. Since there's a minus here, you just minus, and the coefficient of x is 1. You just write, you divide the coefficient by 2, and then plus the half squared, or no, sorry, minus the half squared. Since it's already also minus, you minus the half squared plus 3 by 2, and then you do the square brackets. So now, one second. So now what we do here is x minus 1 by 2 squared minus half squared will be minus 1 over 4 plus 3 over 2. One second, I'll just see if it's right. Yeah, it should be right, I think. Yeah, so then it gives you 1 over 4 plus 3 over 2. And now what you do is 2 times the square brackets, this whole, you just write this as this, and then you just do the calculation for the C, this C coefficient of C, the term C, sorry, and what you will get is plus 5 by 4. And then now you multiply this with the 2 times, you expand it, x minus half squared plus 5 by 2. So I'll just show you the breakdown of these 3 marks, how it is broken down in this type of question. So 1 is to 2 marks is for this. So finding this correctly from your steps, this is for 2 marks, and this C is for 1 mark. So basically the A, B and C, when you find the A, B and C correctly, you will get all the 3 marks. Now let's move on to part B. It is given that fx is 2x squared minus 2x plus 3 for x is less than p. Write down the greatest value of p for which f has an inverse. So you need to know here the concept of how inverse works. So only one-to-one functions have inverse. You need to know this concept over here. One-to-one functions. That means for every x value, there's only one y value for that function has inverse. So now, since we know that the greatest value of p should be the minimum point, because when you draw this graph, I'll just show you how it works. So let's say this is your graph. For every x value, there should be only one y value. But since uh, after so at these points, right, there are more than one y value. So that's why you just take it from the minimum. So only this part of the curve or this part of the curve is taken for a one-to-one graph. So that's why it's that's why we have this kind of question. So this is basically one to many. Yeah, no, many to one. Sorry. So basically, it's for every x value, or for every y value, there can be two x values because of the curve here. So since to make it one to one, you either take so I'll just this part of the graph or this part of the graph. So that's your ideology to when you're working with this question. So that means where they have already given you the range of x. So they are saying that they will take this orange part. So the x is less than this minimum point. So that minimum point can be directly found from this from the completing the square form. And since x, you just need to write the x value. It's the p should be equal to a half. So you need to know that from this completing the square, this should be your x value. Yeah, this should be the absolute x value of the point, x value of minimum point, and this is your y value of minimum point. So this is a concept you need to know when you're solving this. Since it's only for 1 mark, we can directly take it from the completing the square form. And now let's move on to the C. So they're asking using the value of P, write down the range. So the range should be somewhere from this y value, because you need to also recognize that the range is the range of y values. So it starts from the minimum point and increases from there. So that for the range of f should be greater than or equal to 5 by 2. 5 by 2 is your y coordinate of the minimum point. So the y value of the minimum point is 5 by 2. So that's why you do this. So now let's move on to part D. Hope you understood how we found the minimum point and why we used the minimum point to find part B and C. Now using the value of P, find an expression for F inverse. So how to find F inverse from this? So since it's a quadratic equation, you can only find F inverse when the part of the curve is taken. And since they have already given you x is less than or equal to half, you can basically take this. You can take the completing the square form into this question. So what you do here is, this is your equation. So it should be 2 times x minus half squared plus 5 by 2. And always when you're finding the f inverse, you let fx should be y, and then you make the x as the subject, and then and then substitute the value of y to x. So when you're making the subject as x, here it should be 2 times x minus half equals to y minus 5 by 2. This should be a square here. So that brings us to half squared. So then this should be y by 2 minus 5 by 4. The 2 point will be, yeah, it should be 5 by 4. And then when you bring this squared other side, and since it is great, the range is a positive value, you don't need to care about the minus sign. You just write it as, okay, I think you need to know you need to write the minus sign, because it's not about the range, it's about the x. So x is less than negative, less than half means you can include the negative values also. So here, this should be a negative square root of y is equal y by 2 minus 5 by 4. So that's how it works. So it works because why do you write this minus? Because at this point you're taking the left side of the graph, and the graph actually shouldn't look like this. It should be transposed somewhere here, because there is an critical point at half, and then when you move towards the line, it can cross the line of 0. So that's why we use the negative. And then this, as it is, you can write half minus the square root of y by 2 minus 5 by 4. So you just move the negative half to the other side, you get it half. So therefore the F inverse of x should be half minus square root of x by 2 minus 5 by 4. So that's your F inverse. So you need to know that how to find the F inverse, and using the completing the square form, how do you use it to find it, and why we put this negative instead of plus minus when you are doing the square root. So that's it for question number 5. Hope you understood this topic and how we do it without calculator also. So now let's move on to question 6. So this is going to be a little simple because trigonometry, mostly since it is something that involves decimal places and all, when you're doing it with other questions, the in non-calculator paper it should be simple. So here they have tell it is given that tan theta is going to be equal to root 5 over 5, and the range of the tan should be within this. So as per the 4 quadrant rule, this should be either in the third or the fourth quadrant. So since it's, let's just say it's like somewhere here. So and then you draw the axis and this is your theta. So tan theta should be opposite over adjacent. So the opposite should be root 5, adjacent should be 5. And now they are asking you to find cos theta. So cos theta is straightforward. Before you find it, you need to know the hypotenuse. So hypotenuse will be square root of, so let's say this is h. H will be equal to square root of 5 squared plus root 5 squared. Root 5 squared. So that will give you 25 plus 5, which is going to be square root of 30. So now therefore the cos theta will be the cos theta is basically adjacent over hypotenuse, which gives you 5 over root 30. And since there is a there's a root in the denominator, you need to rationalize this. So basically, rationalizing is basically you move the root from the denominator to the numerator. So this should be what you will be getting. And when you multiply both this numerator and denominator by root 30, you get 5 root 30, and root 30 times root 30 will be 30. So this is your answer for this question. And now we will move on to this. Find the value of okay, just give me a minute. Yeah, okay. Now let's find sine theta. So this is part B, sine theta. So sine theta is basically opposite over hypotenuse. So the opposite to the angle theta is root 5. And okay, there's one thing you need to remember here. Since this is on the third quadrant, this is towards the negative. So this should be a negative 5 here. So sorry, I forgot about that. So it should be negative 5 root 30 over 30. And since this is moving towards the negative again, this should be also a negative here. So now this should be negative root 5 over 30, root 30. Root 30. So when you rationalize this, you will get negative. So basically, when you rationalize this to root 30 times root 30. So now what you get is negative root 5 times root 30. So that should be 150, and this should be 30. So let's just check that if it's correct. Negative root 150 over 30. Yeah, it's correct. So hope you understood. Since because it is on the negative axis, you need to include the negative signs. So if you did not, you will lose the mark. So make sure you put the negative sign. Okay. So now part C. Find the value of secant theta plus cos theta. So secant theta plus cot theta is basically 1 over cos theta plus 1 over tan theta. So 1 over cos theta is basically the reciprocal of what we did there. 30 over, or you can write it from negative 5 over root 30. It's going to be root 30 over 5 and a negative, plus tan theta will be root 5 over 5. Root 5 over 5. So from this you can just do the calculation on the numerator. Root 30 over 5. So they're asking you to write it in the form of a plus b root c over root 5. So now you need to make this root 5. Okay. So then what you can do is, then I think you can just substitute the other values as it is, not like this. You don't need to do this. So it should be 30 over what was, sorry, this should be 5 over root 5, not yeah, I got the mistake I made here. So it should be 5 over root 5. It's the reciprocal of the tan. So that's why it's 5 over root 5. So now what we do is, so you just make it to 5 root 5 on the bottom. So this you just do the normal calculation. To make the denominator the same, you just make it negative root 30 times root 5 plus 5 times 5 is 25, and we get 5 root 5 in the bottom. Second now. Okay. So that's your thing. And then now what we do is this should be negative 1 root 50 plus 25 over 5 root 5. So now you just need root 5 in the bottom. So you just write this as, so 150 you can, so 150 is basically 30 times 5. And so that you can make it into some, okay, wait. So 25. So 6 times 25 is 150. So that you can make it 6 times 25 plus 25 over 5 root 5. So now what we do is, so you can separate these two as per the root rational values. So that should give you negative 5 root 6 plus 25 over 5 root 5. Now, as per the answer, you need to write it in A. So 25 divided by 5, you can do it separately. So basically 25 over 5 root 5, you can separate it, minus 5 root 6 over 5 root 5. So now when you separated it, this should give you, this should give you 5 over root 5 minus root 6 over root 5. So now in that form you need to make it 5 minus root 6 over root 5. So the value of b should be 1. So hope you got how we evaluated it. So there is rationalizing involved here and making the same denominator also involved when you're solving this question. Okay, now let's move on to the seventh question. So the seventh question is something to do with this shaded area. So let's just read the question before. The diagram shows part of the curve y is equal to 5 over x plus 1 plus 2 and part of the line y is equal to 2x plus 1 intersecting the point at A. Find the coordinates of A. So that's pretty simple. You just do the simultaneous equations. 5 over x plus 1 plus 2, y equals 2x plus 1. So this is your first equation, this is your second equation. So since both are equal to y, you can just let 1 is equal to 2 and that should give you 5 over x plus 1 plus 2 equals to 2x plus 1. Sorry. So 5 over x plus 1 equals to 2x minus 1. So now 2x minus 1 x plus 1 equals to 5. So you bring the x plus 1 to the other side and you will multiply that. So that should give you 2x squared minus x plus 2x, which gives you plus x minus 1 equals to 5. 2x squared plus x minus 6 equals to 0. So now the x value should be, so 1, negative 6. So here you just need to write the completed form. So it should be 2x minus 3 and x plus 2. So when you do, you get this as your factorized form. And now the answer for x is either 3 by 2 or negative 2. X is equal to negative 2. But I will reject this negative 2. So what's the reason? Because the graph is starting from y-axis towards the positive y-axis or the positive x-axis, positive x-axis. So it starts from the x is equal to 0 and moves towards the positive. So that means since x should be greater than 0, greater or equal to 0, so that's your reason for why you're rejecting the x is equal to negative 2. So now when you substitute this x equal to 3 by 2 in any of the equation, let's substitute it in x equals to 3 by 2 in equation 2. I feel it easier. So the y should be 2 times 3 by 2 plus 1, which is equal to 4. So therefore the coordinates of A you get is 3 by 2, comma 4. So hope you got that. And since it's for 4 marks, you need to know, you just need to write all the steps over here without leaving anything to gain the full 4 marks. Now the part B, find the exact area of the shaded region. So this shaded region, how do you find it? You use integration. So they're asking you to apply the integration to find it. So what I do is they only need till this part. So I just separated it from the the extensions. So basically from here you can see that you can find so from here you can find the whole of this. So this is your whole area of this whole area under the curve is basically this. Sorry, area under the curve should be this, the highlighted area. And you just need to find part of the area which is corresponding or intersecting with the y equals to 2x plus 1. And you can see that there is a trapezium over here. So this is your trapezium's area. So you can separate this trapezium area to be area 1. So this is your trapezium. You can see this is your area 1. And this whole under the curve should be your area 2. And when you find both the areas, you just write area of the shaded region should be area 2 minus area 1. So let's just do it in action. So first area 1 is going to be the trapezium. you know that point A has the 3 by 2, comma 4 as your coordinates. And for this, you need to find this intercept. So where it is meeting, y is equal to 2x plus 1 is, well, the y-intercept of this. So basically that is going to be 1. So from this equation of the straight line, you know that this C, so this is your C, that's your y-intercept. So now you know that this length is going to be 1 unit. This length is going to be 4. Okay, let me do it in a different color. So this length is going to be 1 unit. This length is going to be 4 units. And the height is basically this. So the height here should be 3 by 2. So basically this trapezium is transferred as in the horizontal position. So that's why this is your two parallel lines and this is your height. Sorry. So now the area should be I'll just write the equation here, half times a plus b times h. So a plus b is your two parallel lines and h is your height. So half times 1 plus 4 times 3 by 2. So that you will get it as 3 by 4 times 5. So that should be 15 by 4. So your area 1 is 15 by 4 units squared. So now from here we will find area 2. Area 2 is area under the curve, which is you just use you need to use the integration to find that. And what is your limit from which to which? So it's basically from this x is equal to 0 to x is equal to 3 by 2. So that's your limit. So you use definite integrals over here. So definite integral of 0 to 3 by 2. And the equation should be 5 over x plus 1. 5 over x plus 1 plus 2 dx. So now so this is basically, you can write this as integrate to 0 to 3 by 2, 5 times 1 over x plus 1 plus 2 dx. From the ln x rule, so when you divide 1 over x, so integrate 1 over x, you will get ln x. So that's your property over here, you need to remember to integrate this portion. So this portion corresponds to this. So now what we do here is you just write the square brackets, and this should be 5, the coefficient you can leave it as it is, and then ln, this x is basically transposed as x plus 1. So you can write ln x plus 1 brackets. And then this plus should be plus 2x, and the plus c is not required because in definite integrals the c and c will get cancelled when you're subtracting the both from the formula. So 0, 3 by 2. So now you write this as 5 ln 3 by 2 plus 1 plus 2 times 3 by 2. So that's your first part, minus 5 ln 0 plus 1 should be 1 plus 2 to 2, or no, plus 0. So that's basically this. So now your area 2 should be 5 ln 5 by 2 plus 3 minus 5 ln 1 will be 0. So ln 1 is going to be 0. So you just leave it as it is. So this is your area 2. Now therefore area shaded. So now you're going to find the area shaded. Should be A2 minus A1. As we said, the whole area under the curve minus the area of the trapezium will give you the area shaded. So this whole thing 5 ln 5 by 2 plus 3, and then what we got there, 15 by 4 minus 15 by 4. So now this you can just expand and then find 3 minus 15 by 4 should be, I believe, negative 3 by 4. That's your answer. You just leave it in the exact form because they told here your exact area. You don't, since you also do not have the calculator, you can just leave it in the exact area. So this is your exact area. Let's move on to the eighth question. So the eighth question, I think there's a lot of questions here. So how many total? Oh my God, there's still 12 questions. Okay, it's fine. We still have time. So let's go with the eighth question. The first term of the geometric progression is 10. We know we just write the information in algebraic form, so it's easier. And it's a geometric expression. The geometric expression has a positive common ratio R. The first term of an arithmetic progression is also 10, and the common difference is D. And it has a negative common difference, so this should be negative D. The second term of the geometric progression is same as the fourth term of the arithmetic progression. The third term of the geometric progression is same as the sixth term of the arithmetic progression. So this find R and D. So this for 6 marks. So we need to just use all the information to find the R and D. So we need to find two values. So we need two equations. So you can remember by this. The number of values corresponds to the number of equations you need to form to do the simultaneous equations. So they have the first information they gave is the second term of the geometric progression. So the second term T2, or I'll say let G to be the geometric progression and A to be the term A should be the okay, I'll use the T itself because A is already used. We have used, so I don't want to confuse you. So arithmetic progression. So this is your arithmetic progression. So now G2 is equal to T4. That's your first equation you need to form. So how do you find G2? From the general term, Tn is equal for an arithmetic is AR n minus 1. So A, you know, it's 10 times R is going to be the same. Okay, it's positive common ratio. So R to the n minus 1 is 2 minus 1 is going to be 1. So it's 10R. So basically this is 10R is equal to, and you know that for an arithmetic progression, so this is for G, this is for A. Okay, so the arithmetic progression will be A plus n minus 1D. So that's your general form of the term to find the term, and it's a fourth term. So basically 10 plus n minus 1 is going to be 4 minus 1 is going to be 3, and since it's a negative common difference, we write negative D. So don't forget the negative sign. So it's important to write the negative sign so that you don't make any mistakes in this. So 10R equals to, or I think it's better since they just told you it's a negative, so it's fine if you don't use the negative, sorry. So you can just write it as D. So when you find the D, it should be a negative number. So 10 plus 3D. So that's your first equation. Now for the second equation, they have given the next information as the third term of the geometric progression. G3 is going to be same as T6. So G3 is basically 10 times R to the n minus 1, which is R squared, equals to T6. So A is 10 plus 6 minus 1 is 5T. So that's your second equation. Now you just solve the simultaneous equations for this. So the first thing you can think of is taking from from one. So I use substitution here because since we have r squared and r, it's better to substitute. Or you can do the division method also to eliminate the r. So here from 1, we take r is equal to 1 plus 3 over 10d. 3 over 10d. So that's your third equation we formed. And you need to substitute this 3 into 2. So r should be 1 plus 3 by 10d squared equals to 10 plus 5d. So now basically what you do here is 1 plus 3 by 10d squared equals to 1 plus half d. So I just divided both sides by 10. And now you expand this 1 plus 3 by 5d plus 9 by 100 d squared equals to 1 plus a half d. And now you bring everything to the same side. 9 by 100 d squared. This 1 and 1 gets cancelled. So then 3 by 5 minus 3 by 5 minus 0. The half will be plus 1 by 10d equals to 0. So now we can bring 1 by 10 outside, 1 by 10d outside. So 9 by 100 divided by 1 by 10 would be 9 by 10d. 9 by 10d plus 1. So 0. So when you move this, that's a 9 by 10d plus 1 equals to 0. D should be negative 1 times 10 by 9. So what I here did is first you need to transpose the negative, you subtract both sides by negative 1 and then you divide both sides by 9 by 10. So when you divide this by 9 by 10, you get negative 1 times 10 by 9 is going to be negative 10 by 9. So that's your D. And R, you just substitute the D into one of the equations. Most probably the third one, because you already know that that's going to be the R. 1 plus 3 by 10 times negative 10 by 9. So that should be 3, 3, 10, 10 gets cancelled. Negative 1 by 3 plus 1 would be 2 by 3. And that's your answer for D and R. So you found D is equal to, so I'll just write the answer here. D is equal to negative 10 by 9 and R is equal to 2 by 3. Hope you understood. That's a long process actually. So, and it's worth 6 marks. So it should be long. So I think no problem in doing that there. And let's move on to part B. Determine whether the geometric progression has sum to infinity. So any sum to infinity, so any value that has a sum to infinity, it should follow this condition. So the condition for any geometric progression is going to follow this. So basically the condition, let me write, it's a condition. You need to remember the condition is the negative, so the absolute value of R. So the absolute value of R should be less than 1. So that's your condition. You can expand this to say that it should be in between negative 1 and 1. So that's your the expanded form or the generalized form. So you need to just check if the R is between this. So since R is equal to 2 by 3 and 2 by 3 is less than 1, or the absolute value of this 2 by 3 is less than 1. Therefore, the geometric progression has a sum to infinity. So that's your suggestion and your explanation for your answer. So that's pretty straightforward. It's only for 1 mark. And let's move on to the next one. Solve the equation. So this is basically simple, and it's going to be using the logarithms laws of logarithms. So as you can see, we just write this log 2x plus 1 minus 4 log x plus 1 2 equals to 3. So the first logarithm law, I'll just write all the logarithm laws we'll be using here. The first step, or the first logarithm law we'll be using, is log AB is equal to 1 over log BA. When you reciprocate, the basis and the value can change. So when you use that log for log law, you will get, and I'm going to use it for this. So I'll just shade for which one we are going to use it. So then this is going, sorry. So minus 4 times 1 over log 2 x plus 1. So your first ideology when you see any logarithms law, you need to make it to the same basis to evaluate it easily. So that's what we did. So we made it to the same base as log 2. And then when you expand this should be log 2x plus 1 minus 4 over log 2x plus 1 equals to 3. So now when you make the same denominator, this should be log 2x plus 1, and this will be log 2x plus 1 squared minus 4 equals to 3. So now log 2x plus 1 squared minus 4 equals to, you transpose the denominator to the other side, you will multiply it with 3 log 2x plus 1. So now we bring all to the same side. Minus 3 log 2 x plus 1 minus 4. Now you might be stuck here, but there is a solution to this. How do you find it? Very easily. So the point here is, one second, you can see that the log 2x plus 1 is common for both two terms. So now basically you can substitute that log 2x plus 1 to be some other value. So let's say it's something like y. So let y is equal to log 2 x plus 1. Now you substitute this y for the equation. Y square minus 3y minus 4 equals to 0. Now what do you get? A quadratic equation. Quadratic. Now you just need to solve this quadratic. Now you just need to solve this quadratic and then make the solution to be log 2x plus 1 and then solve it. So that's going to be pretty simple over here. 1 minus 3 minus 4. You will get y minus 4, y plus 1. So that's your factorized form, and then y is equal to 4 and y will be equal to, or y is equal to negative 1. Now you substitute that for log 2x plus 1 equals to 4, or log 2x plus 1 equals to negative 1. So when you move the log 2 on the other side, it's basically going to be 2 to the power 4. X plus 1 equals to 2 to the power 4. So the law we use here is log AB equals to C. If you want to find the B, you do A to the power C. So that's your log law here. And that's what we did here. And there's another solution to this x plus 1, which is going to be 2 to the negative 1. So x plus 1 is equal to 16, or x plus 1 is going to be a half. X is equal to 15, or x is equal to negative half. So that's your two of the solutions for this question. So note that it's for 5 marks, and you have given a full page to do it. So just notice the number of marks should be the number of steps or the number of knowledge you need to use in that particular question. So now let's go to question 10. We have 2 more to go after this. So the point P lies on the curve this. The x coordinate of P is 5. The normal to the curve at P intersects the line at the point Q. The point R is the reflection of Q in the tangent to the curve at P. Find the coordinates of R. A lot of information given. So you can just recognize that this is from coordinate geometry. From the topic of coordinate geometry. So the first thing, when you recognize that this is the topic, it's better to just sketch whatever the information is given. Sketch all the information given. So now when we sketched it for x and y, we have some we'll just do a rough sketch. I'm not going to do an exact one. So the point P lies on a curve. So let's say this is your curve. So that's your curve over there. And the x coordinate of it is going to be 5. So let's say this is going to be P 5 comma y. So now the normal to the curve P, to the curve at P. The normal, so here we need to draw. So basically this is your tangent. Okay. To draw the normal, you know that a normal is always perpendicular to the tangent. So when you draw the tangent, the normals will be perpendicular to it. So somewhat like this, and there is a 90-degree angle over there. So that's your normal, and this normal intersects for x plus y equals to 11. So basically that's going to be a random. This is your, okay, let me just label everything so it's getting clearer, getting a little messy. So basically this curve over here, this blue line is going to be y is equal to that 5x plus 2 to the 2 by 3. And this is your tangent and this is your normal. So let me just give the normal. And now, different color. Okay, so, and now we draw the x plus y equals to 11, something like this. So let's say this is your x plus y equals to 11. And this is going to, okay, that doesn't matter. So then they told that this is your point P. So it's intersecting the normal at point Q. Sorry, Q. So at this point Q, where it is going to be A comma B, let's say. We don't know the coordinates of Q. And the point R is the reflection of Q in the tangent to the curve P. So this is your tangent. And it's going to be the reflection. So basically the point R is also going to lie on this normal, but on the opposite side. Same by the same amount. So if this length is x, this should be also x. So that's your R, where let's say C comma D. So we need to find C comma D. Let me shrink that and get some space. So what's your first method or ideology you're going to use for the first step? The first step is going to be simple. You need to find the coordinates of P. So y coordinate of P. And since the P is on the curve, you can directly say that when x is equal to 5, the y is going to be equal to 5 times 5 plus 2. You just substitute it with the curve, the equation of the curve, and you will get 27 to the 2 by 3. That's going to be the cube root of 27 squared. So that should be 3 squared, which is going to be 9. So hope you got that. That's your first step. So then you can just write the P's coordinates to be 5, 9. Now you need to find the equation of the normal. So this is the first step, we did it. Second, equation of normal. So to find the equation of normal, you need to first find the equation of the tangent, and that's going to be your gradient basically at that point. And when you find the gradient, you use the differentiation. So dy over dx, use that. So that for that you just okay. Let me just write the formula so that it's easier for you to see. So the y of the curve is 5x plus 2, 2 by 3, 2 by 3. So when you do dy over dx, you bring down the 2 by 3, 5x plus 2, and then reduce the power by 1, negative, by 1. So that should be giving you 2 by 3 minus 1, negative 1 by 3. And don't forget to differentiate the inside. So that's your chain rule over there. Don't forget to differentiate the inside function. So we used chain rule. So just remember, I'm just writing it for your understanding. We use the chain rule. So then this should be 10 by 3, 5x plus 2, negative 1 by 3. So now at that point P, when x is equal to 5, what is the gradient? So basically, you substitute the x is equal to 5 to the gradient. You find gradient. So this is basically you're finding gradient of that tangent. Gradient of tangent. So that should be 10 by 3, 5 times 5, which is going to be 25 again, 27. So 25 plus 2 will be 27, negative 1 by 3. So that should give you 27 to the negative 1 by 3, 10 over 9. So that's your gradient of the tangent. Now to find the equation of the normal, which is also straight line, you need to find the gradient of that normal. So the m of normal, m for gradient of normal, you need to know here the m1 times m2 is going to be negative 1. So this is your equation for perpendicular lines. So as we know that tangent is always perpendicular to normal, we use this formula to find the gradient of normal. That should be negative 1 divided by 10 by 9. It's going to be negative 9 by 10. So equation of normal, we found the equation of normal. Now you know that the normal is passing through 5, 9, and then you just find the find the equation. So therefore the equation of normal is going to be, here you use this formula again, y minus y1 equals to m times x minus x1. So that's your formula for equation of straight line. Now I use that, I get y minus y1 would be 9 and the negative 9 by 10 x minus 5. Now y minus 9 is equal to negative 9 by 10x plus 5 to plus 9 by 2. So y is equal to negative 9 by 10x plus 27 by 2. So that's your equation of the normal. So we found the equation of the normal, we found the p's coordinates. Now it is time to find the q's coordinates so that we can find the reflection, that is the r. So the third step is to find coordinates of q. So how are we going to do that? So you know that the q is the intersection point of the equation of the normal and x plus y equals to 11. So basically you do the simultaneous equation to find the coordinates, because you need to find the x and y coordinate. There are two values, two equations as before. So then y is equal to negative 9 by 10 x plus 27 by 2. So that's going to be the second equation. So basically you can just substitute 2 into 1, x plus negative 9 by 10 x plus 27 by 2 equals to 11. So that's going to be a 1 minus 9 is going to be x by 10 plus 20 is going to equals to 11 minus 27 by 2. That's going to be negative 5 by 2. Now the x value should be negative 5 by 2 times 10, which is going to give you negative 25. So that's for your x coordinate. So then therefore the y coordinate, you just substitute the x into the equation, negative 9 by 10, negative 25 plus 27 by 2. You will get y is equal to 36. So therefore coordinates of q is negative 25, 36. So 5, 9, negative 25, 36. Now you need to find the reflection of r. How do you do that? Find coordinates of r. So that's your last step. Find coordinates of r, which is the reflection. Let me just bring this graph so it's easier for you to see how we do that. So we have both p's coordinates and q's coordinates, which is going to be 5 by 5, 9, and q is going to be negative 25, 36. So from here, the reflection, you know that it's going to be the same distance from PQ. So the thing for reflection here is the PR is going to be equals to PQ. So you can just basically compare the coordinates and then find the coordinates of R. So it's going to be the same. So 5, how much? So to transpose from 5 to 25, what is the length? So that's going to be negative 30. And since we know that it's negative 30, we just so since from here from A to this 5 is negative 30, you just add that 30 over there. Or wait, let me give you a better picture of this. I will just write it in the different order. So first we have Q. So this is your order QPR. So let me write it in that order. Negative 25, comma 36, and P is going to be 5, comma 9. Now let's do the transposing. So from negative 25 to 5, you need to add 30. So therefore, for R, the x coordinate of R. So I'll just write it x coordinate of R is you need to add 30 from this 5. 5 plus 30, which is going to be 35. Y coordinate of R is basically again you need to compare 36 and 9. So from 36 to 9, you need to minus 27. You need to do negative 27. So that same thing you do with 9. So that should make you 9 minus 27, which is going to be negative 18. So therefore, the coordinates of R is going to be 35, comma negative 18. So hope you understood all the 4 steps, all the 4 major steps. First is going to be finding your P, coordinates of P, then the equation of the normal, coordinates of Q, then coordinates of R. And hope you understood the transposing, how we did for by comparing the each of the coordinates. Now let's move on to question 11. 2 more questions to go, 11 and 12. In the diagram, OA is OA. So the vector OA is going to be A. OB is going to be B. The M is the midpoint of OB. So that means from here to here it's going to be half B. And from here to here it's going to be a half B. The point N is such that ON is 3 times the NA. So if we say that this is one part, there's going to be 3 times of it. So basically you can think of this as 4 parts. The A is divided to 4 parts, and this is 3 parts of A, or you can say 3 by 4 of A, and this is 1 by 4 of A. So that's how we are going to divide this information over here. So this information implies that you're dividing OA into 4 parts, and 3 parts belongs to ON, and NA is 1 part. The lines BN and AM are intersect at point X, as we can see in the graph. BX is lambda BN, MX is lambda MA. Find OX in terms of AB and lambda. So OX is basically, you can think of it as, so BX is lambda BN, right? So OX can be split into OB plus BX. So OB is basically B plus lambda BN. So this BN you need to find. So that's going to be lambda times. So from B to N you can go from BO plus ON. So BO plus ON. And when you go the opposite side, you need to remember the sign. There's going to be negative B plus ON is, as we know, that is going to be 3 by 4A. So now OX is B plus, or let's write it as this. Let's write it in first A. So 3 by 4 lambda A plus 1 minus b, 1 minus lambda b. So that's how we can factorize it. So hope you understood this part. So I'll just, if you did not, I'll just write here what we did. B minus lambda b. We brought b outside and then 1 minus lambda. And I wrote it as like this. So that's your first part A. Part B, find OX in terms of A, B, and mu. So mu is containing from mx. So OM plus mx. You can think of OX as like that. OM plus mx. So OM is half A. Oh no, half B, sorry. It should be half B plus mx is mu of MA. So just telling the symbols if you don't understand. So this is called lambda and this is called mu. So this is mu. And now half B, you can think of MA now. You can see the same thing as for MA. It's going to be MO plus OA. MO plus OA. So that should give you half B plus mu of MO would be negative half B. You're moving on the other side, negative half B plus A. So that should give you mu A plus half minus a half mu B. So that's OX for in terms of AB and mu and OX in terms of lambda AB. So then find the mu and lambda. So there are two constants you need to find. Then you have two equations for OX also. So you can just write OX going to be 3 by 4 lambda A plus 1 by 1 minus mu B. OX is also equal to 1 minus lambda B. It should be lambda B is also equal to mu A plus half minus a half mu B. So now since the both are the same, you can just compare the coefficients. So the coefficients is you can just say that 3 by 4 lambda is going to be equal to mu. That's your first equation which you formed. And when you compare the for B, the coefficients of B, it's going to be half minus a half mu. So we found two equations. You substitute 1 into 2. So when you substitute 1 into 2, you will do 1 minus lambda equals to half minus a half 3 by 4 lambda. So 1 minus lambda equals to half minus 3 by 8 lambda. So now when you move lambda here and negative 3 by 8 plus 1, so that should be 5 by 8. 5 by 8 lambda equals to a half. Lambda is going to be equal to half divided by 5 by 8, which is going to be half times 8 by 5 to 4 by 5. So lambda is 4 by 5. Now you just substitute lambda into equation 1 and mu would be 3 by 4 times 4 by 5, which is going to be 3 by 5. So you found your answers. answers as lambda is going to be 4 by 5 and mu is 3 by 5. So basically used simultaneous equations here by comparing the coefficients of A and B. Now let's move on to the last question here. It is given that y is equal to x to the e to the x 3x plus 2. Find dy over dx. So that's going to be simple. So you just recognize here this is x times e to the 3x plus 2. So we use the product rule. So the product rule is basically if you have fx times gx, when you want to differentiate, you do fx g prime x. So first you differentiate one, then add, differentiate the other, f prime x gx. The same we are going to do it for this. So let's do the first with x. So when you differentiate x, it's going to be 1, and 1 times e to the 3x plus 2 is going to be e to the 3x plus 2, and add with x, and you need to differentiate the e to the 3x plus 2. So remember that it's going to be the same, but you need to differentiate the power and then make it to the coefficient. So that's going to be 3. So then you can just write it in a simpler form. You when you factorize the e to the 3x plus 2, you will get 1 plus 3x e to the 3x plus 2. Hence find the integral of x to the e to the 3x times e to the 3x plus 2. Okay, so this hence question, you need to use the differentiation to find it. So dy over dx, what we found before, it is e to the 3x plus 2 plus x to the e 3x plus 2. So basically what they're asking you to do is make x e to the 3x plus 2 as the subject. So that should give you dy over dx minus e to the 3x plus 2. And when you integrate this, x e to the 3x plus 2 dx, you just integrate this whole thing, dy over dx minus e to the 3x plus 2 dx. Now when you integrate dy over dx, we know that differentiation is inverse of integration. So both are inverses. So when you make a differentiated form, when you integrate a differentiated form, you get the same as your your first equation. So the original equation, you can just copy that 3x plus 2. So we use the thing, differentiation is the inverse of integration to do this question. To do this dy over dx. So when you integrate a differentiated form, you get the same function back. And then when you differentiate this, you write it as the same. But now since you're integrating it, you need to divide it by the differentiated of the power. So that should be 3. And then add the c. Do not forget the c. There might be a constant, and when you differentiate the constant, it's gone. So just remember to add the c when you're doing a integration of indefinite integration. Sorry, yeah. So hope you understood this paper, and we have come to the end of this past paper walkthrough. If you have understood everything, then it's great. If you have any doubts, you can post it in the comments below or to our WhatsApp group, and let us know if you found it helpful, and do subscribe.